In this example, we're looking at how we can rearrange 5 letters from the word north into 2-letter words. For the sake of clarity, we'll define words as simply rearrangement of the letters as opposed to what you'll find in a dictionary. So this is a permutations problem because we're looking at different rearrangements based on elements of a set. So what we'll do is we'll take those elements, in this case the letters N, O, R, T, H, and we'll just go through very methodically and see how many 2-letter words we can arrange. Of course, we could start off the words with the letter N, or O, or R, or T, or H. So there are our 5 possible starting letters. Let's look at the letter N first of all. Now the second letter, if we start with an N, could be an O, or could be an R, or could be a T, or could be a H. So what we've done is we've actually exhausted all the possible 2-letter words starting with N. And if we repeat that same idea with the different letters, we'll see that we've got 20 possibilities of 2-letter words coming from the word north. The easiest way to perform the calculation to get this result would be to say that for the first letter we've got 5 choices from the word north, and then once we've chosen that, for the second letter we've got 4 possibilities. So if you like, there's 5 lots of 4, or 20 ways we can express 2-letter words from the word north. Another way we can perform this calculation is using a formula. If we take one of the 2-letter words, in this case no or NO, we can see if we extended that to 5 letters, there'd be a further 3 factorial or 6 possibilities. That's using the letters R, T and H, which we can see here in green. So the number of ways that we can get 2-letter words is actually 5 factorial, and then we divide by 3 factorial because that's all the further options we could use with the remaining 3 letters. And you'll see that if we do that, the 3, 2 and the 1 cancel, and we're left with 5 multiplied by 4 on the top line. So the number of ways to get 2-letter words from 5 letters can also be expressed as 5 factorial divided by 3 factorial. And that 3 factorial is actually got by finding the difference between 5 and 2. 5 being the number of letters we had to choose from, and 2 being the letters that we want to make into our new word. So let's look at the general case when we want to select R objects from N objects, just like before we wanted to select 2 from 5. So the number of ways is N factorial, that's the number of possible choices that we've got, and it's divided by N minus R factorial, where R is how many we're actually selecting from the original number of objects. And we can write that as a formula. The P stands for permutations, and we write N for the number of objects we're selecting from at the top, and R being the number of objects that we actually want to select. We of course need to keep in mind that once we've made these selections, permutation refers to the different arrangements or different orders we can have for the selections we've made. So let's have a look at an example where we've got 5 numbers, in this case the digits 1 through to 5, and we're looking to make a code. But to clarify this, we're saying that repeat numbers are not allowed. So we're looking at all the different arrangements, and because repeats are not allowed, we're looking at permutations. So we'll write this as 5p3, and that means that we've got 5 objects and we're selecting 3 to rearrange into different orders. And using our formula, what we do is we put 5 factorial on the top of a fraction, and the bottom line is 5 minus 3 factorial. And of course 5 factorial, if you calculate that, comes to 120. And 5 minus 3, which is just 2, is 2 factorial, which is just 2 times 1 or 2. So the number of ways is 120 divided by 2, which comes to 60. So there are 60 ways to rearrange 5 digits into 3 number combinations without repeats. And here's all of those 3 number combinations actually listed, so we can see that there are 60 ways to actually select those 3 numbers and rearrange them into a different order. Let's have a look at the same sort of problem very briefly and see what would happen if repeated numbers are allowed. And that becomes a much simpler problem because what we can do is say for our first digit selected, there are 5 possibilities, and then for our second digit there are still 5 possibilities, and for the third digit there are still 5 possibilities. So the number of ways is 5 multiplied by 5 multiplied by 5, which comes to 125.